All right, so let's attack this problem on related rates. First of all, from trigonometry, you need to remember these trig identities, that the tangent is the opposite over the hypotenuse, and the secant is 1 over the cosine, and you're going to need these values that you would have used to answer questions on the first assignment, Appendix D. So let's go to the next page. I'm going to keep those values with us. I've got a plane flying horizontally. Got a little tail on the end of it there. And the altitude is 6. And the angle is pi over 6. That's 30 degrees in case anyone cares. And the angle is changing with respect to time at a rate of negative pi over 3 radians per minute. And what I want to know is how fast is the plane traveling? How fast is x traveling? dx is what I'm looking for. Now we know from our basic trigonometry identity that the tangent of this angle is going to be 6 over x. The tangent of this angle is going to be 6 over x, which I can write as 6x to the negative 1, either way. And that the tangent of pi over 6 from my chart here, the tangent of pi over 6 from my chart here is the square root of 3 over 3, and that equals 6 over x, and cross multiplying, I get 18 over the square root of 3 for x. Now, you can clean that up if you want to. Rationalize your denominator. You're going to get a 6 square roots of 3. This is a fine answer. You can use that one, just this one's going to look a little nicer. So x is 6 square roots of 3. And one other thing we're going to need to know is that the cosine of my angle, the cosine of pi over 6, is the square root of 3 over 2. So those are the pieces we're going to need for the next part. That the cosine equals the square root of 3 over 2, and x is 6 square roots of 3. So let's go to the next part. Now from trigonometry, we know that secant squared theta times d theta equals negative 6 x to the negative 2 times dx. Now x we just figured out was 6 square roots of 3. And the secant was the square root of 3 over 2, so the secant squared, the cosine was the square root of 3 over 2, so the secant squared is going to be 4/9, and d theta is negative pi over 3. All that's from the last page. Now, algebraically, when I clean that up, I get negative 6 over 36 times 9, and that cleans up to be negative 1 over, canceling a 6 out, 54. And this is times dx. So I now have negative 4 pi over 27 equals negative 1 over 54 dx. And canceling the negative out of both sides and multiplying both sides by 54, I get cancel the 27 out of both, and I get a 2, which gives me 8 pi. So that's how fast the plane is traveling at that time. Hope that helps.